I'm Alexander Kholodov. I'm research associate with Geophysical Institute, University of Alaska Fairbanks, and I do permafrost research. It's what I do for my life. And now it's summertime. What we are doing, we prepare the equipment, some sensors to measure temperature, permafrost temperature, ground temperature, surface temperature, air temperature. Will be deployed this summer in different places around the world, both in Alaska and in Siberia. And now we are gonna to calibrate all our sensors. What does it means? So, and what we are doing it for? So here is the data logger with 4 temperature sensors attached, and all these sensors will be deployed in different location. This particular will be on ground surface and three depths inside the soil. So we launch this logger, and you can see it. As you can see, it's all 4 sensors stay in one location, but in general, they all 4 of them show temperature like 22 centigrades and with some hundreds. But in hundreds, it's a kind of big difference between. So it's 22.44, and the lowest and highest is 22.75. So it's like 3/10, roughly 3/10 difference. When you do just your room temperature measurements or even temperature measurements outside, gonna like decide what clothes you want to wear, it doesn't really matter. But for us, tenths of degrees, it's a big difference between, because it's exactly the like annual trend we are trying to catch, like changing in temperature and time. So to make all this data comparable, we need to figure out the true temperature, real temperature, and then we will use this offset to calibrate all our records. What we are doing, we need to put all sensors in environment with the temperature we know exactly, and the easiest way to get this temperature is to prepare a mix of distilled water and crushed ice made of distilled water. So it will be a technical exact point of distilled water or distilled ice melting, which is exact 0 centigrades, exact freezing point. And then we will compare all temperature from all of our sensors to this 0 point. So to prepare this mixed, we will use a bottle of distilled water, just regular blender you can purchase in a store. We try to use a lot of equipment you can purchase in just regular stores, or because it's inexpensive. Here you can see it's a good picture. Slashing, water saturate, and Okay, and you see now it shows 0 with some thousands even, and it takes some time for sensors to equilibrate, because all sensors have their own heat capacity. One channel, actually channel 1 for some reason doesn't work really good. Okay, it does. So let's put some more sensors on this. So we are starting data loggers right now, and each data logger will do measurements now every 10 seconds. So equipment we use for long-term continuous observations, we do calibrate before installation, and we also have some equipment we use every year for one-time measurements, and we calibrate it at the beginning of field season and at the end of field season to see what we don't have any trends we measure which caused not by the natural processes but by the equipment we use. Let's wait. Okay, we are ready to read out data, and we'll see how how good our equipment is. And this new data logger equipped with a screen, you can really see. So it still shows different temperature. All channels show different temperature, but now we know what real temperature is, 0. So we can use this offset later and just subtract this number for each channel from data we will measure. Okay, come here, you can see it on the screen. Here you see the temperature dynamics on all 4 channels, and it seems it is a huge, but the scale of y-axis is very detailed. So the actual difference is 0.1 to 700. So it's not that bad. And now when we know it, we can say it's very precise. We can make our measurements more precise. And yeah, now I'm gonna just read out data from all this stuff, all these loggers, and archive it somewhere, so everybody will use data from the data loggers equipped with the sensors will know what they can get offset data. That's it.
Thank you.
You're welcome.
Yeah, so it's calibration of this sensor here, which we'll use to measure temperature in the borehole, and it's supposed to show 0 at the ice bath, and it's showing minus 0.004. So perfect. So okay, we're good to go.